Hi everyone, welcome back. Let's write some more Leetcode today. I will go over two ways to solve this problem, but I will only show the code for the optimal solution. So if you're only interested in the optimal solution, then feel free to skip to the timestamp. So the problem states that we are given an integer array called nums, and every subsequence of nums is considered a square streak if the length of subsequence is at least 2, and after sorting the subsequence, each element is the square of the previous number. So what does that mean specifically? Well, let's look at this example. We have a subsequence of 2, 4, and 16 because 2 times 2 is 4, and 4 times 4 is 16, and therefore that makes us the length of subsequence 3, and that is the longest one. So the output of that is 3. And if we go through the entire array, but there was no subsequence or that is considered a square streak, then we will just return -1. So how would we solve this problem? I think the most common way to solve this is to first sort the array, and as you sort it, you will look through each element in the array, and every time you look through the element, you will take the square root of that number, and you want to check if the square root of that number is in the hash map. And if it is not in the hash map that we designed, then you will just set the value of that number to 1, and if it is, then you will add 1 to that number. So let's go through this example. So first we will sort the array, which would be 2, 3, 4, 6, 8, and 16. So now we will look through each array, right? So 2, take the square root of 2. Is in the hash map? Of course not, because in the first one, so we'll just set it to 1. And then we will look at 3. The square root is not in it, so it will also be 1. Now we look at 4. The square root of 4 is 2, and it is in the hash map, so we will add 1 to it. So 4 would be 2. Now we will look at 6. 6, take the square root, is not in the hash map, so just set it to 1. And then 8, the same thing. The square root of 8 is, I believe it's 2 rat 2, so it's also not in the hash map, so just set it to 1. And then 16, the square root is 4, which is in the hash map, so we will add 1 to that. So 16 and 3. Yeah, so after we have gone through all the elements, then we will look for the highest value in the hash map, and that value is 3 for this example. So the answer would be 3. And the time complexity of this, it's not the optimal time. We'll get to the optimal solution later, but it would be n log n, just because we have to sort the array, and sorting would take n log n time. And the space complexity would be O of n, where n is the length of the array, because this hash map can go up to as long as the length of the array can go. So the more efficient way to solve this problem is to just take the initial array that we were given and turn it into a set. And we will look through each element in the set. But when we see an element, we will take the square root of it. And if it has a square root in the set, then we will skip it, because we know for a fact that will not lead to the longest square streak. So if we take a look at 4, it has a square root which is 2, so we will skip it because 4 alone will not make the longest square streak. Now if it does not have a square root in it, then we will multiply by itself, or in other words, to square it. And if the number that we square is in the set, then we will change the value of the result if it makes it greater than the current result, which is -1. So let's go through this example, right? So we look at 4. 4 has a square root, so we skip it. We look at 3, square 3, which is 9. 9 is not in the set, so now we move on to 6. Squaring 6 makes it 36, not in the set, so we skip it. We look at 16. The square root of 16 is 4, which is in the set, so we skip it again. And we come to 8. 8, we take the square root, which is not in the set, so we square it, which it becomes 64. And 64 is not in the set, so we skip it once again. Now we get to 2. The square root of 2, not in the set, so now we square it by its own. 2 times 2 is 4, so now we could change the result. Now the result is 2, temporarily. And now we look at 4 and square the following number. 4 times 4 is 16. Oh, so now we can change the result again, because it's longer than 2. So now it's 3. And then now we try to square 16, but that is not in the set. So our final result is 3. The time of this would be O of n, because we have to look through each element, and n is the length of the array. And the space will also be O of n, because we have to make a set, which is the length of the array. So yeah, now let's get to the coding part. So first, I'm going to make a set, and then we'll call it num set. and we'll set the initial result to 1. And now we're gonna loop through numset, and then we'll call the index n for numbers. And if the square root of the number, if it's in the numset, then we just skip it. So we'll do continue. Else, then we will do a temporary number and set it to 1. And then we'll square it. And if it is in the numset, then we will obviously change num to the square of it. And then we will increment current by 1, and then each time we go through the else statement, then we will try to find the maximum result by checking if cur is greater than result. And finally, if the result is still -1, then we just return -1. Sorry, that was a typo. Or else, then we return result. All right, let's see if it works. Submit. All right. Well, thanks for watching. I hope this was helpful. If you guys have any other questions, comments, concerns, feel free to leave it down in the comment section below. And I hope to see you all again soon.